Now coming to the second combination which we can have in a circuit using capacitors. This is known as series combination. So for series combination, as the name suggests, obviously हमारे पास capacitors, we will be having these capacitors connected in series with the battery. So now we have this positive terminal connected to this side of the conducting plate. Obviously this is positive, attracting all the electrons, so leaving all the positive charges on the capacitor. If this is positive, obviously negative will be here. So this one is negative, all the positive charges are attracted to this side of the terminal, leaving all the negative charges over here. And if this is negative, obviously the conducting plate will have the positive charges on it. So there's this gap between them. So obviously the charges are not allowed to flow through the circuit. So there is an electric field from positive to negative, and this field is in this direction. We know that it originates from positive and moves towards the negative side. Let this be capacitor 1, this be capacitor 2. When we have capacitors connected in series, here the voltage will be V1 and V2. But in this case, the charges present on this capacitor will be equal to the charges present on this capacitor and the total charge. So one thing which you must remember is when the capacitors, they are connected in series, the total charge is equal to the charge on capacitor 1 and the charge on capacitor 2 and so on. But the potential of the battery, it has its own value. V1 has its own value and V2 has its own value. So we need to calculate these because the potential will be different across these capacitors. Charges are the same, and for that we must have to find the equivalent capacitance of the circuit. So as we know, the formula is Q is equal to CB. Here we will find V. For that, V is equal to Q over C. So this is, let this be A. And for V1, we may write, for V1 we may write Q1 over C1, and for V2 we have Q2 over V2. This is B and C. Now to find the total voltage, can we write V equals to V1 plus V2? Simple. And for that, let it be equation 1, putting A, B, C, A, B, and C in 1. So I'll be having Q over C equivalent equals to Q1 over C1 plus Q2 over C2. we have already discussed and as shown in figure that the total charge within the circuit, it will remain same. So we can write Q is equal to Q1 is equal to Q2. So which is equal to Q, say. And for that, if I want to simplify it, can I take this Q common? And I'll be left with 1 over C1 plus 1 over C2. Cancelling it and get this equal to plus 1 over C2. We can further simplify this. This is the equivalent capacitance for the capacitors that are connected in series. So I'll simplify this so that we may know how the final value will come. So to simplify it, just take the LCM. CEQ. LCM will be C1, C2 and C2 plus C1. And I'll cross multiply C1, C2 over C1 plus C2, which is equal to C equivalent. So this is how you can find the equivalent capacitance of the capacitors that are connected in series. So if we have more than 2 capacitors, we may write it as for more than 2 capacitors. We may write 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3 and so on. And simple addition problem, you take the LCM, you simplify it, and you'll get the equivalent capacitance for a circuit having capacitors connected in series. So if you remember, when it comes to resistors or series combination, the formula was R equivalent is equal to R1 plus R2 and so on. So one thing is clear from these two combinations, that when we have resistors connected in series, we get this result, which is more like the one we have obtained for the capacitors connected in parallel. And from here, we see that when the capacitors, they are connected in series, this result resembles the one that we have seen for the resistors connected in parallel. So it's sort of a reciprocal. Okay, now again a point to remember, just to to find that whether the equivalent capacitance you have calculated for the series combination is correct or incorrect, that the total equivalent capacitance that you will get will be less than the capacitance of the capacitor present in the circuit with the smallest value. So जो भी smallest capacitance आपकी है circuit में present, ये equivalent capacitance जो आपकी आएगी, it has to be smaller than that. So it's a check whether the calculation you have done is correct or incorrect. अगर तो ये कहीं बीच में लाई कर रही है, सपोज आपके पास एक 1 का है, एक 2 का है और 1.5 इक्विवेलेंट कैपेसिटेंस आ रही है, तो it is confirmed that you have done something wrong while solving. So go back to the problem and try to resolve the issue, whatever you have done during solving the problem. So it's just a check that whether you calculation. Okay. Sorry. Here. I have this. Okay, I'll get the values. I have three capacitors. Let's draw it again. Okay. Now I have capacitor 1, capacitor 2, capacitor 3, and a battery terminal, positive and negative. The values are 4 volts, C1, C2, C3. It is 1 microfarad. Let this be 1 microfarad and this be 2 microfarad. Okay, now I want to find the equivalent capacitance for this circuit. I know that dB is equal to 4 volts. C1 is 1 microfarad, C2 is 1 microfarad, and C3 is 2 microfarads. Now to find the equivalent capacitance, it is very simple. Just use this formula. 1 plus 1 plus 1 by 2, taking the LCM, that is 2 plus 2 plus 1, 5 by 2, 1 over C equivalent. So if I want to find the value of C equivalent, I will have 2 over 5. So 2 over 5 is approximately equal to 0.4 microfarads. So this is the value of our equivalent capacitance. So if I have this equivalent capacitance equal to 0.4 and the smallest value of equivalent capacitance is 1 microfarad. So from this calculation, one thing is confirmed that okay, I have calculated the equivalent capacitance equal to 0.4, which seems okay for me because this value is less than the value, smallest value present in the circuit. Now I'll draw the equivalent circuit for this, and which is so C equivalent is equal to 0.4 microfarads, and I have this 4 volts plus minus. So this is the equivalent circuit, this is the equivalent capacitance. Now further, if someone asks, okay, now you have the equivalent capacitance, so why don't you tell us what will be the total charge? So simple, the total charge will be, I know that Q is equal to C over V, and I have the value of V, I have the value of C equivalent over here because I'm calculating the total charge. So this is 0.4 divided by 4 into 10 raised to the power minus 6. So the value will be 1.6. I think I've done something wrong over here. Q is equal to CV. So I have to see that is 0.4 into 10 raised to the power minus 6 into 4. So 1.6 into 10 to the power minus 6 coulombs. So the total charge will be 1.6 microcoulombs. Now, if I want to find the voltage drop across these capacitors, so simply I have the value of charge, I have the value of capacitance, so I can easily calculate V1, V2 and V3. So V1 will be equal to 1.6 into 10 raised to the power minus 6 divided by 1 into 10 to the power minus 6. This is actually Q over C. So micro goes with micro and I am left with 1.6 volts. V1. Okay. V2, it has the same value, it has the same charge. So can I write V1 equals to V2? Because 1 microfarad, similar procedure will be followed. So I'll get V1 equals to V2. For V3, okay, I'll write it over here. For V3, the charge is 1.6 into 10 raised to the power minus 6 because overall charge will remain the same when the capacitors they are connected in series combination. So the value of capacitance there 2 into 10 to the power minus 6. Again, this goes with this, and I am left with 1.6 divided by 2 gives me 0.8, 0.8 volts. So this is for V3. Now to check whether I have calculated the voltages correct or incorrect, there is a simple check that the total voltage must be equal to the sum of all the voltages. So I know that our VB is 4. This is 1.6. Yes. Plus 1.6 plus 0.8. So the sum of all these must be equal to this. 3.2 plus 0.8. This gives me 4. So this shows that I have calculated the voltages correctly, and this is all about your series combination. So just remember one thing, class, be very careful with the units, be very careful while noting that either you are going for the series combination or the parallel combination, because if you make a mistake, if you confuse yourself with capacitors and resistances, then there will be a big problem. Whatever you have learned for the resistors,